Hello, in this video I'm going to go over the Mathematics Standard 2 trial for 2021 and just go through the solutions and possibly a different way to answer questions that you might not have thought of when you did it in the first place. So, of course, we're going to start off with multiple choice. Now, question one, the answer to question one, what is the best description between the colour of a person's hair and a Year 12 student's success in HSC, is zero correlation, and that is because the colour of a person's hair does not relate to success, so therefore there is no correlation there. For question two, we've got a car uses an average of 7 litres of fuel per 100 kilometres travelled. How much fuel would the car use if it travels 382 kilometres? So what this, the information we have is that 7 litres for every 100 kilometres. Okay, so what do we have to do to get 100 kilometres to be the same as 382 kilometres? Okay, whatever we have to do there will get the number of litres used. So I guess if we think 100, and what do we have to times 100 by to get 382? Well, it's going to be 3.82. If we do that, multiply this by 3.82, we get 382 kilometres. So if we do that for the 100, we need to do the same thing for the litres. So if we do 7 times 3.82, we get 26.74 litres, which is our answer for A. Question 3, we're looking at the time taken to paint a house varies inversely with the number of people painting the house. Which graph represents this relationship? Well, it's important to recognise that inversely looks like y is equal to k on x, okay? And that looks like this on a graph, like a hyperbola. Like that, and that is the positive version of a hyperbola. Now, when we're talking about the number of people and time, we only care about this aspect, the positive for both. So which one looks like that? It's A. The other way to think about it is if I have one person painting a house, that's going to take me a very long time to paint that house. But if I have 10 people, it's going to take a lot less time. So that's what an inverse relationship is. Next, for a network diagram, we've got, we need to find the number of vertices with odd degree. So in order to do that, I'm just going to number the number of the degree for each vertex. So here we've got 1, 4, and remember we're just counting the number of lines coming from each. That's 4, 4, 2, 3, 4, 3, and 1. I'm just going to highlight all the odd ones. 1, 2, 3, 4. The rest are even. So the answer is B, 4. Next, we need to calculate the area of the triangle below to the nearest whole number. Now, if we're going to find the area, we need 2 sides plus the angle in between. So we have these 2 lengths, but we don't have that angle in between, but we do have 2 other angles in the triangle. So we can do 180 minus, so the angle sum of a triangle, and we take away those 2 angles. We get 100 degrees. So if that's 100 degrees, we can then use the area rule for a non-right angled triangle, which is a half AB sine C. So quickly labeling the triangle, that has to be C, so it's little c, and the others don't matter as much, because if you did them around the other way, you'd still get the same answer. So my A is 35, my B is 49, sine 100. If we type that into the calculator, we get 844.47 so on to the nearest whole number is D. Next, for 6, we need to use the table above to calculate the present value of an annuity where $15,200 is contributed each year, 5 years into account, earning 2% per annum compound interest. Okay, so 5 years, I'm going to highlight some things. 5 years, 2% per annum. And because it's happening yearly, we can just use that directly into the table. So what's 2% for 5 years? We get this number here. Now we need to find the present value of an annuity. Okay, and the way, because this is a present value table, all I need to do is just multiply 15,200 by that number, and then we'll get our value. Which is C. Next, question 7. Which equation describes this straight line graph? Okay. Now the important thing to recognize is which options can we remove straight away? Well, I can remove this one immediately, and that's because it cuts the y-axis here at 15. So because these all have plus 15, that's telling me that it's that's the y-intercept, because the way we write it is y equals mx plus b. M's the gradient, b is the y-intercept. So to get our gradient here, the best way is the rise over run. So we look at the distance of the height. I'm going to do it in a highlighter. So this distance here is the rise, and this distance here is the run. So M is rise over run. The rise is 15, and the run is 5, which gives us 3. But you'll notice, so that means it's definitely not C, but you'll notice that one's positive, so one is negative. Because this line is pointing to the left, the up arrow is pointing to the left, that means it's negative, because everything over here is negative. If it was pointing this way, that means it's pointing more towards the right, which means it's positive. So that means the answer is B. That brings us to the written questions. So for question 8, we have to find the value of M when V is equal to 0 for that formula shown. So for this, I'm just going to put in brackets and include 2 whenever I see V. Now I could simplify that on paper, but I'm just going to type it straight into the calculator at this point and see what I get. I get 33. M is equal to 33. Next, after completing a numeracy test in percentage, Hazel has achieved a z-score of -1. How does Hazel's result compare with those of her peers? Explain your answer in terms of the mean and standard deviation. Well, if you remember a normal distribution, something like that, this is the mean here. And the mean for, in terms of z-scores, is 0. So having a score of -1 is saying that the score is 1 standard deviation below the mean. And that's what we need to write. So you'll notice I used the words standard deviation in my response and mean, and they wanted my answer to be like that. Now, If it was positive 1, we would say 1 standard deviation above the mean. Basically, what we're looking for is, can you see that it's a positive and negative, and how does that reflect on a normal distribution curve? Next, for B, if the mean test mark was 81 and the standard deviation was 3, we need to calculate Hazel's actual mark. First of all, I'm going to write down the z-score formula. Because we have her z-score, the mean test mark and the standard deviation, we can calculate her actual mark using the z-score formula. The formula, of course, is x minus the mean over the standard deviation. So when I substitute in the values, I get negative 1 is equal to x, because that's what we don't know. The mean is 81, and the standard deviation is 3. Now I can solve to find what x is. First of all, I'm going to multiply both sides by 3 to get negative 3 is equal to x minus 81. And I'm going to add both sides with 81 to get, what's 81? Negative 3 is 78. So that is the score. So I might give that a highlight to say that that's my answer. Next, Avis sells soap bubble makers for $10 each at a market. Each bubble maker costs her $4.25 to build, and she has to pay a fee of $50 to sell these at the market. We need to write an equation to describe the relationship between costs and the number of bubble makers. So I'm going to highlight some things in the line above. She sells each bubble maker for $10. That's not relative to the cost. So this second sentence here, each bubble maker costs her $4.25 to build, and she has to pay a fee of $50 to sell these at the market. Okay, so what that's telling me is the cost is going to always be $50. But then, for every bubble maker she makes, that costs her an extra $4.25. And so that's where the n comes in. This is relating to how many bubble makers she needs to make. Next, B says, how many bubble makers must Avis sell to make a profit? Now, this is where we're talking about break even. Now, there's a couple of ways to go about this. You could use trial and error. If you use trial and error, you could be really fast. It could take a long time. It depends. So, first of all, let's consider the cost. The cost we've worked out is that. But what does she earn? She earns $10 for every single one. So we'll use I for income. She gets $10 for every bubble maker she sells. Okay, so essentially, there's a couple of ways to do this. Some people use the formula of profit is equal to income minus the cost. So I'm going to do it that way, and then I'll do it a different way, just so you can see some variation. So the income is 10n, and the cost, which you notice I'm using brackets here, is 50 plus 4.25n. First thing I want to do is I want to expand the brackets. Because this negative here applies to the 50 and the 4.25, I need to rewrite it. Now I'm going to add and subtract like terms, so I'm going to do that with you'll see 10n and minus 4.25n, so I'm going to do that. So 10 take away 4.25 is 5.75n minus 50. Now at this point we might be thinking, where do we want to go from here? Now in order to make a profit, that means that she needs to be making more money than what she's selling. So the break-even point is when, I'm just going to make a note over here, break-even when profit is equal to 0, meaning she's not, in this case Ava, is not making any money, but she's not losing any money either. So here I'm going to let p equals 0. So now we have this. So now we just want to get n on its own. So I'm going to do that now. If I add 50 to both sides, I'm going to get 50 is equal to 5.75n. And I want to get n on its own, so I'm going to divide both sides by 5.75. When I do that, 50 divided by 5.75 gives me 8.695. But the problem is, she needs to, she can't sell or make part of a bubble maker, so it must be 9. 9 bubble makers to make a profit. Without going into complete detail, another way of answering this question is to consider, once again, the cost and the income and make them equal to each other. So if I was to do that, I'm just going to make a line to say I'm doing it differently. If I did 50 plus 4.25n, which is equal to 10n, that's when we get break even, and then we can solve in a similar way. So if I take away 4.25n from both sides, so I can get all the n's on one side, get 50 is equal to 5.75n. And then you can see there, from this point onwards, I'll highlight it. From here, it's the same solution. Now, one thing that's important is what I've done in purple. At first can seem a bit more complicated, but it is faster. So you have to make that decision when you're answering questions like this. Moving along, we've got a question here. In the region of a tropical forest, 96 rare birds were captured, tagged and released. 5 months later, 72 birds were recaptured from the same region, and it was found that 18 of these birds had previously been tagged. Use the capture-recapture method to give an estimate of the number of rare birds in this region of the forest. So, we need to look at a couple of aspects. I'm going to highlight them as we go. So, we've got 96 rare birds were captured. And where some people go wrong with this is they don't consider how many they are being captured of. 96 birds were captured out of the population. I'm going to use just the word pop for that. It's a bit easier to write. And we need to make that equal to, if we look here, 5 months later, 72 birds were recaptured, 18 were tagged. Okay, so that means I've got 18 out of 72 which are tagged. So I've got on this top line here, these are all the tagged birds. This is the total number of birds. Okay, so we need to find out what the population is equal to, and that is how we get our full marks. That's how we get our answer. So what I like to do first, this is similar to the sine rule, is I like to flip everything. So I want the population on top, because if I have the unknown on top, it's a lot easier to calculate. So if I do that, I'm going to have the population over 96 is equal to 72 over 18. And that's still true. Then I'm going to times both sides by 96. So the population is going to be equal to, and I'm going to type in my calculator, 72 over 18 is multiplied by 96 is equal to 384. And that gives me the answer. Next, we have a sphere, diameter 15 centimeters. We need to find the volume in cubic meters, centimeters. Give your answer correct to 3 significant figures. So first of all, the formula. The volume of a sphere is 4 on 3 pi r cubed. That's on the reference sheet. Then I need the radius. Now the diameter is 15 centimeters, so the radius is half of that, which is 7.5. Now if I type in this into the calculator with 7.5 as the radius, I get, so 4 on 3 times pi times 7.5 cubed gives me this calculator readout. Okay, that's what the calculator says. I like to do a couple of dots because I'm assuming it keeps on going. Now the three significant figures is the first three non-zero digits rounded. So it's going to be 1, 7, and then the 6 becomes a 7, and then I finish with a 0 as a placeholder for the ones. And that's to centimeters cubed. That's question 12. Question 13 is about Amelia. She invested $8,000 in a simple interest account and a compound interest account. Interest in both accounts is paid annually. After 15 years, the total value of the simple interest account is $21,800. What is the amount of interest paid annually? So, I'm just going to rewrite that in a bit shorter. In 15 years, the account now has $21,800. Okay. Now the first thing we need to consider is how much of that is interest. So she started off with $8,000. So if we do 21,800 minus 8,000, we will get the interest. So the interest, if we do that, is 13,800. So that is the net amount of interest in 15 years. So to be able to get it annually, we just need to divide 13,800 by 15. So if we do that, 13,800 divided by 15, we get $920 in 1 year. So what I've done is I've divided everything here by 15. I've divided this by 15 to get 920, and I've divided this by 15 to get 1. Next, might finish that with a dollar sign actually. After 15 years, the total value of the compound interest account is $24,000. What is the annual compound interest rate? Answer is a percentage to correct to 1 decimal place. So, what we need to do here, first of all, I'm going to write out the formula for compound interest. Now, after 15 years, so it started off with $8,000. After 15 years, the final amount is $24,000. Now, we want to get R by itself. So the first thing I'm going to do is divide both sides by 8,000. When I do that, I get 24,000 divided by 8,000 is 3. So 3 is going to be equal to this, 1 plus R to the power of 15. But I don't want that power of 15 there. So the opposite of that is the 15th root. Okay, so I'm going to put my 3 in there. So I'm going to put 3 in there. So if I do that, I want to do the 15th root of 3 is equal to 1 plus R. So I've gotten rid of that and the brackets as well. Now before I type that into the calculator, I'm going to do the next step, which is to take away 1. Because if I do that, I'm going to have R by itself. And if I type that into my calculator now, I get this, 0.07598996, and so on. But as a percentage, that's just a decimal. As a percentage, if I times it by 100, I get a percentage. So the percentage is 7.6%. That's to 1 decimal place. That's the answer for B. Question 14. We have a block of land in the shape of a quadrilateral, ABCD. The diagonal AC has been drawn. Then we have some information. That information is actually directly on here already, which is good. We need to find CD to the nearest metre. So I need this length here. Now, what information do I have? I'm going to look specifically at this triangle here because I have information. I've got these angles, I've got this side length. I have this side length and this length here, but I don't have this angle. I don't have this angle. I don't have this one either. So I have to use this triangle here, at least for now. So I've got that side and this angle and they match. They go together. Okay. If we look at a different side, we've got this side here and this angle here, and they go together as well. So when we have a pair like that, we have the sine rule. So we're going to use the sine rule. And the sides are known. I'm going to call it x. So we're going to have x on sine of the angle opposite, which is 53, which is equal to 75 on the angle opposite, which is 32. And we want x on its own, so I'm going to multiply both sides by sine 53. When I do that, I get x is equal to 75 sine 53 all over sine 32. And you type that into your calculator. 53 on sine 32. We get 113.0316, so on. It says to the nearest metre, so we're going to write that as 113 metres. Now, I would have answered that on the lines, but it was so you could still see the picture. Moving on. Frankie's credit card has a no interest-free period. Interest is charged at 0.039% compounding per day. Interest is charged on the date of purchase, but not the date the account is paid. In May, Frankie made only one purchase on the 7th of May, a pair of shoes for $85. Frankie paid the account on the 1st of June. Calculate the total interest paid charged for May. So there are 31 days in May. Okay, that's important. 31 days in May, not being charged on the 1st, because that's when interest was paid. So we're going from the 7th to the 31st, okay, including the 7th. So that's going to be, if we do 31 and we take away 7, we get 24. But the problem if we do that, we actually only get, we're excluding one of the days. So the better way to think about it is to count from the 7th and go 7th, 8th, 9th, 10th, 11th, 12th, and so on. And if you do that, that total number of days is 25 days. Okay, so we've got 25 days, including the 7th and including the 31st. Next, we need the compound interest formula. So the amount is going to be 85, 1 plus the rate, which we got given. We don't have to change it because it's already daily. And the number of days, which is 25. When we type that into the calculator, we get $85, 83 cents, and so on. But we want just the interest. So the interest is going to be 85.8326 minus 85. So the total amount of interest is $0.83. Next, we've got question 16. Harley builds a model of a fighter aircraft. The model is made to scale of 1 to 250, and then we've got 80 millimeters there. The length of the model is 80 millimetres. What is the length of the real aircraft in metres? Well, first of all, what this is saying is that every millimetre on the scale is 250 millimetres in real life. So the first thing I want to do is do 80 multiplied by 250. When I do that, I get 20,000 millimetres. Now, to get it from millimetres to centimetres, I like to use this. Okay, now to go from millimetres to centimetres, we're going to divide by 10, and to go from centimetres to metres, we're going to divide by 100. Not that it matters for this one, but if we needed to go to kilometres, we divide by 1,000. So we need to divide 20 millimetres by 10, and then again by 100 to get to metres. So if we do that, we're left with 20 metres as our answer.